And this is the final project video for EC551, and our project goal is Flappy Bird. I'm Yaowei Tsai. I'm in charge with the mobile app development.
My name is Xiaofeng Su. I'm responsible for the communication.
I'm Zhenbang Liu, and I'm in charge of the VGA.
I'm Pengfei Liu. I did the in-game logic.
So the UR connection here serves as a median for keyboard and cell phone via Bluetooth to our FPGA board, and we can control the bird's position by either the cell phone or a keyboard. So 3 moving barriers with opening is adjustable, and multiplayers allow a maximum 2 players to control the bird at the same time via cell phone and keyboard. And we can score counting, which means that we can calculate how many sets of pipes that you have passed. And during the game, you can pause and either resume. The resolution is 640 plus 480. The bird goes to animation, which means that their wings flaps, and the background is colorful and HD.
You won't let me go, 'cause I'm not this acceptable houseware. You emptied out the bar with him, and he let only tells which bar. Others might sleep, yet these are what I don't hold you when you were young.
So for the detailed block diagrams for the main logic, there are 2 inputs, keyboard and Bluetooth. They are connected to the main module by 2 UART modules. When they go into the main logic, they will be decoded to 1 hot code, so they can be identified by functions in the main logic more conveniently. Then they will go through an automatic switch, so if you connect a Bluetooth device, the keyboard input will be blocked. It will also useful for the multiplayer function. The inputs are used for the bird position control and the main state machine control. There is also a random number generator to generate barriers randomly. Bird position and barrier positions are used for the collide control and the score counter. After that, the state, bird position, barrier position, and the score will be outputs to VGA module for display.
Functionality of our project, as you can see, we use this FPGA board carrying out this main logic of the game. We also use this Bluetooth module, which for Bluetooth communication. So you can use a laptop, a cell phone app to control our Flappy Bird. Also, if you don't have a Bluetooth, you can also control it through a USB cable, whatever this command line you're going to use. This is a UART communication. As you can see, it's a 8-bit packet consisting the ASC code, and our baud rate is 9600 Hz. The sampling is at 10 times offset Hz. So this is UART communication. It's duplexing, which means you can either transmit or receive data at the same time. Here we face 2 main problems of our project. One is that we have a small lag while controlling this bird, and sometimes about 1 out of 10 packages will lose one. So to address this problem, we use this error control mechanism, but this Bluetooth chip doesn't support parity bits, so I just use a ecosystem, which means when you send a bit, it will resend what you just sent. So if when you send and receive them to match each other, you need to.
For the bird position control, we try to simulate the effect of gravity. So if you push the bird up, it will go up for a while and then go down with increasing speed. There are 3 angles for the bird corresponds to different speed. To realize that, we have a timer for the bird, and it will get reset when it's put up, and it will increase automatically. The speed is calculated from the bird timer.
In the VGA part, MATLAB code was used to convert the image to the COE file, and it can detect the transparent pixel automatically. Each object has its own priority, and max were used to arrange the object to different layers. 7 birth states of each bird, and divided to 3 groups. And the logic part gave me the group index, and the VGA made it fly. So this bird, you can see there. This is how there was 2 challenges on the VGA part. One is how to make the game high definition, and because of the limited memory on the FPGA, there was 2 solutions to achieve that. One is use compressed image, and the first method is to use index image, and it will save about 1/2 of the space. The MATLAB code can convert the generate the Verilog code, as you can see on this page. In the red circle and in the blue circle, it shows how to convert the alpha pixels onto the transparent pixels, and this is transparent. This is generated Verilog code, and the second method is to store the only useful area, like in the background image. Above this is all blue and below this is all green, so only this part of image is need to stored, and only small image, some of the image is stored as small image, like the game over, easy, medium, and something else. It makes the resolution lower but acceptable. And our failure was the SD card. Is the SD card because the time was limited, so we did not got this, and it will be a future plan of our project.
Here I'm gonna talk about the Android layout and button implementation. If you can remember that last time we demoed, there's a little bit delay between Bluetooth connection. That's because we register different listener for Android. The listener here works as a method and defines what to do in the button when you press. So we change the method from on-click listener to on-touch listener. On-click listener is like when you press a button, and once you release the button, the function will go to work. But on-touch listener is like when you press, the function will go into work. And on the right hand side, you can see the picture is the rating bar change listener. It's like for you to choose the gain level. And here you can see. And to talk a little bit about Bluetooth connection, first you need to register Bluetooth adapter, which is used to find the nearby devices. Then we get that device address, and we use the address to create IFCON circuit, which is most reliable and stable Bluetooth protocol. And here you can see that our Bluetooth connection is mutual. On the picture, F means that we press the button, we send an F to the FPGA board, then we get an F back. So this is how we debug to see if there's any omission between our Bluetooth connection. Since every Android phone are equipped with motion sensors, we think that we can use shake motion as a way for user to play like Flappy Birds. So shake motion is like we find the acceleration force from the XYZ axis, then we define the threshold speed. Once the overall acceleration force exceeds the threshold speed, This is a shake motion to be detected.
也是一个微处理器。那个调状态，你这边码我告诉你。全部定格起来。
让他干点啥？
录完了吗？
反有特写，经典中正面的才是。
Slow down, let's just say, build a fort and talk like we were kids. When we didn't know nothing of this, when we didn't know nothing of this. I'll get sheets and you get candles and we'll make our own tents and candlelight. I will obsess without the bed of lights. We'll start within the tent of trust. And I'll let you see me and I'll see you. And we will know each other through and through. I'll see you and you'll see me. I will have our own tents and candletree. My heart today, today.
好的，一会儿摇一个。
超了哈，然后 FPGA 好，重新编一编就好使了，就立了，就说明咱们程序没问题。